Dear learners, the topic for discussion and for today's video lecture is a new topic. It is DICM, Differential Interference Contrast Microscopy. This is one of the topic which we shall be learning today and discussing with respect to the one more type of microscopic advancement and a modified version. So just a brief review. Till now we had learnt about the basics of light, that is the light properties. We learnt with the very first topic, the first video lecture, we learnt about the basic properties of light, what is meant by a lens. We learnt about the description of reflection, refraction. Then in the initial topics and video lectures, we learnt about bright field, dark field, phase contrast. And today we shall be learning a new topic which is based upon differential interference contrast microscope. So the learning objective for this session would be to elaborate on the principle and working of a differential interference contrast microscope. Now when you want to study about the basic principle and working, you should first know regarding the topic of phase contrast. So those who have not yet seen the video on phase contrast, they are hereby requested to first watch that video on phase contrast microscope, with the help of which you will have a base, and it would be better if you first watch the video of phase contrast and then come to this. So now taking for granted that the viewers and you all have seen the video of phase contrast microscope, we shall now move on to the use of differential interference contrast. So the basic principle is very much similar to the phase contrast microscope, and here it is based upon creating an image by detecting the differences in the refractive indices and thickness. Now dear learners, here you should remember that the same basic principle was useful and it was applicable for phase contrast also, where the certain regions of a cell are thick, certain are thin, and they differ in their own refractive index. So here two beams of plane polarized light, they are used, and both of them are at right angles to each other, and this could be generated by prism. So I believe you all remember the prism. You all must have used it in your physics experiment while performing some of the practical experiments on light. So by using a prism, we could have a provision for two beams of plane polarized light. So in one design, the objective beam will pass to the specimen, while the reference beam, the second beam, will pass through a clear area of the slide. We know that the whole surface of the slide will not have the object. Some region will have, some of the area will be covered by the object, but some of the part of the slide will be free, clear. So in one design, the object beam will pass to the specimen, whereas the reference beam will pass to a clear area. So once they have passed, after passing to the specimen, the two beams are now combined and they will interfere with each other to form an image. So a live specimen which is not stained, it could be seen with a bright colored and 3D view of that. So with the help of DICM technique, it is possible to observe cell wall, endospore, granule, vacuole, and eukaryotic nuclei which are clearly visible. I'll show you one picture. So this is how the micrograph of a protozoan. So here it's an DICM image, a micrograph image which is taken with a differential interference contrast microscope. It is of amoeba proteus. So the 3D picture will have a considerable degree of detail, and it is artificially colored, 160 times magnified. So thank you for listening to this brief video on DICM. Keep exploring the world of mini wonders.